This is a video on modular SLAM workflows, how we can combine separate steps into workflows that solve the mapping and localization problem for a whole variety of applications. Each application will have its own workflow potentially, and we want to do so efficiently and at scale and provide access to this technology en large. So the main value add of SLAM and by extension SLAM workflows is that as we sort of go more into the 21st century, in various sectors, including construction, the built environment, warehousing, logistics, driving automation, mobile robotics, across many sort of sectors, marine, terrestrial, airborne space, will all benefit from and come to rely on more advanced tooling, equipment, sensors, computational aids that help the humans do their jobs more efficiently. To do so, to advance this equipment further, there's a key bottleneck. And this is the ability for computational systems to have an efficient understanding of the 3D surroundings that they operate in, both geometrically and semantically, and to allow more autonomous and integrated operation with humans. The artificial systems and humans have to interact in the 3D space. So if a human says XYZ coordinate in the world, or if the computer says it, the other party has to understand that clearly and be able to work efficiently. So to do this, to overcome this key challenge, requires solving of a whole plethora of problems, broadly referred to in the names such as mapping, localization, navigation, perception, and registration. Now, many of these problems are challenging and costly to master sufficiently for a product. So let's just review what is SLAM. Simultaneous localization and mapping is a popular name. It's also known as the navigation problem. And in broad terms, it's the idea of building digital maps of an environment and doing so by using a combination of available input data, which can be provided or captured raw from sensors. Many types of sensors, by example, with cameras, LiDARs, radars, ranging equipment, gyroscopes, accelerometers, rotary encoders, the list goes on and on and on. Building maps while localizing using one or multiple sensor platforms or vehicles working together is another good example of the SLAM problem. Taking many of these trajectories, so each data recording that happens could be combined together. So either one device moves through the world, or the same device moves through the world many times, or multiple devices move at the same time, or multiple devices move at different times. And we need a clean and efficient way to bring multiple versions of this data together and build the maps, localize the equipment in the maps, make it accessible to humans, make it accessible to robotic agents. So this, there's a whole slew of challenging problems, specifically imperfect data, operating in challenging environments, data ambiguities, computational limits, etc., etc. So to solve this, the proposal is to use modular workers for SLAM. So a SLAM problem can be broken into many steps, and different applications usually want different variants of a SLAM problem, but they can all be broken down into steps, and many of these steps are overlapping or common. So one particular application may have a sequence of 10 modular steps, another one might have a sequence of 12 modular steps to solve that specific problem. And the best way to grow and build value here is to have each of those individual steps in a modular fashion that we can mix and match as needed as problems come up. The most efficient way for solving cloud problems is that we can rapidly not only sort of chain these together, but sort of change those chains a little bit. So maybe a sequence of steps is linear, or there are parallel flows in steps. One worker triggers another worker, or one worker triggers two workers, any of these combinations of steps. So just to give examples of such modular worker steps, but it's by no means a complete list, is maybe you want to ingest data from some known raw format such as ROS bags into something that's more processable, like a graph representation. Maybe it's undistorting camera images given a calibration file. Maybe it's calibrating cameras. Solving graph inference problems that relate to SLAM. Once you have a solution, exporting it to a map format that the user can download. Finding common features amongst different data logs could be another example. This is valuable in loop closure and other operations like that. So just looking a little bit at a manifestation of combining workflows, what would this actually look like? A modular worker may be implemented in any programming language. Maybe it's Python, maybe it's C, maybe it's Rust, maybe it's Julia, maybe it's something else. And it could run on different compute hardware. Something might be GPU intensive or CPU intensive or memory intensive. It might require a cluster of computers, and maybe it runs on a single small processing unit or FPGA. So a worker could run anywhere in any sort of spread fashion. It can be triggered in any way and store its results somewhere in some kind of format. Invocation of a modular worker may be done through either scripting it, just cold scripting a bunch of sequence steps, or by some eventing architecture or publish subscribe method where one triggers another, or a graphical user interface where user chains together they want to have these workers go together in this fashion. And then these workers will pull data, execute on that data, and then restore the results in a way. And the flow of this overall could be sequential, parallel, looped environments. And there's quite a bunch of flavors and variety of what this could look like. So how would users discover available modular workers? It's by any means. So if there's a library of SLAM workers that's hosted as files in a folder or line items in a text file, or maybe it's visual interface elements in a graphical interface or otherwise, and users may want to write their own workers that slot into a workflow, whether it's their own idea or if it's something they pull from the internet, that could be anything. Users can create their own workflows through a combination of modular workers. So user A might chain a certain string of workers in a way that's all sequential. Worker B might, and worker A might do it sequentially through scripting. User B might do it through a visual chain that they use some graphical tool for. Another person might use reactive computational elements. So the fact that a SLAM worker can be used in different programming environments, in different user interface environments. Maybe there's a master orchestration because it's a very robust, repeatable process that gets done, or it's completely distributed, it's not centralized at all, where many of the working elements across the network react to each other and ultimately solve the problem more in a swarm-like fashion. So just to make that a bit more concrete, let's just look at two examples. So example one might be there's an application that requires, at minimum, these steps, probably more, that data gets ingested from LiDAR and camera into a standard graph representation and stored. Then another process looks at LiDAR scans and registers them to each other to get a motion odometry model from them. The graph representation and how these things are stored as they've been ingested then gets modified with these odometry results. The numerical inference is then performed on this computational structure, which basically solves the mapping problem. And then there's another process that takes a standard graph format and exports it into a physical file format that a user can use. So that would be a download. A different application example might require that input data is in a non-standard or a strange format that first has to be converted in some way to an intermediate format. Maybe it has to be calibrated. That data is then ingested as a second step as before. So step 2 is the same as step 1. In application on the right-hand side, step 2 here is the same as step 1 on the left-hand side. Then another unique step, solve for calibration values specifically from that format. Then again, modify a graphical representation, do numerical inference on it. Then take this graphical representation and combine it with previous graphical models or previous data so that you can build a larger map. Then resolve for a second time, so step 3 and step 6 will be the same as step 4 on the left, maybe. Then again, export the map. Step 7 is on the right is the same as step 5 on the left. And then there's an additional, maybe publish the result to someone that you know is listening, or a user or a stakeholder or robotic agent. So these are just two examples of how similar but different steps can be chained together into a workflow to solve the specific problem. So let's just look at manifestations of how data is represented, stored, passed around on a network, and processed. So a crucial aspect in combining modular SLAM workers into a workflow is that the separate input data from different applications could be wildly different and strange, all kinds of file formats. Maybe it's text files, maybe it's binary files, each in their own proprietary sensor format or something like that. Gets organized into a more process-ready format that you can more readily do computations on. And a good example of that is into graphical type models, pose graphs or factor graphs, computational graphs, and then that can be converted further into tree representations which don't have cycles in them. Computational graphs, junction, cluster, elimination, or Bayes trees are good examples there, but by no means a complete list. So this idea of taking very random data that's hard to compute and bringing it into a ready format that many different SLAM modular workers can work on allows that freedom to chain and combine and mix and match more readily. So then for performance and flexibility, data storage can be further optimized by splitting the data off to store different things in different places. If certain computations are high performance and run on GPU, that can be processed in one, but you don't have to pull all the data. So data can sort of be divided up, divvied up, and indexed in reference to each other in useful ways and strategies that are sensible, that are both work well in centralized and decentralized compute and storage architectures. So workflows can be spread over a divergent network of compute and storage infrastructure. So solving a graph might work well on one computer or one set of computers, one cluster of computers, or storing the data might work well on a different kind of hardware that's optimized for high performance data retrieval. So these previous workflows, these steps could live on very different kinds of infrastructure and different kinds of applications. If it's an on-vehicle solution, everything fits onto one computer with multiple threading. But if it's a cloud kind of instance, it could be spread over a very wide set of infrastructure and compute nodes, etc. So when this compute and data storage happens, can also be spread out over time. It doesn't all have to be sequential. It could take days or weeks or minutes or hours for any of these steps or the entire workflow to complete. And there could be many cost drivers or application-specific reasons for that. Some applications might want once a month, once a week. Others might want near real-time performance. So to make such SLAM workflows work, we need to empower users to have tools and products that simplifies this process. That's one of the key elements. If you want to build something that an end user can readily tie pieces together, tie different modular workers, SLAM workers together into solving a problem, the end user wants to be able to ingest a ROS bag, do a calibration, and solve a graph. So tooling to make it easy for the user to tie and chain those elements together is really critical. So what we want to do is amplify how a user can solve the SLAM problem without necessarily being a deep expert in it themselves. So how they discover these different tools that exist, that library of tools, how they chain it together in their preference as before, whether it's scripting or whether it's visual interfaces. That piece of tooling is key. All right. Come back for more on additional performance benefits. Thanks.